Okay, hi. um, I'm gonna try to do a video today that shows how to use your TRS-80's function command. Um, it looks like this. Define function. So that's what it looks like. And then in parentheses, you put a variable. Usually it's x in math, and then you make it equal to your formula. And today I'm going to be looking at something that's called the what is it called, the y-intercept form, which is a line that is a diagonal on a graph. And so the formula is y equals mx plus b. And what this is that it says b is where your diagonal line will cross the y-axis, and m is the number that determines how steep the slope will be. If it's a positive slope, it will go this way, from left to right, diagonally like this. It'll look like that. And if this number here is negative, the m, then it will slope the other way, this way, and b determines where it crosses the y-axis. So I'm going to try to write a program here that will demonstrate this feature. And I'm just going to put slope intercept for the name of this small program here. And we're going to first define three different functions. So we're going to define function A, and that is going to equal, we'll put, we'll try 1 times x. We're going to have to do this a different way. 1 times x plus, we're going to have it cross at the y at positive 1. And our next function, we're going to define function b, and b is going to be multiplied by 2. The x will be multiplied by 2, and it's going to cross at 2. I might have to change these. I really haven't done this in a long time, but we're just going to start real basic and see what we get, and then modify it if it needs to be modified. So here we have y equals 1x plus 1, 2x plus 2, and 3x plus 3, so they should cross at 1, 2, and 3 on the positive y-axis, and they should, I think they're going to increase or decrease in positive slope. Now, I'm not sure which one, if it's going to get the slope will be nearer 1, 2, 3, I'm not sure. And the other problem with this computer is I have to invert all of these functions because we're going to get everything going the wrong way. So it's supposed to go from left to right. We're going to end up with everything going from right to left if we don't invert it, because of the whole problem with the grid, you know, that I talked about in the bell curve video. But this is going to be my last math video. So now I already did 2, so this is the third one. I said I was going to do 3 or 1 more, and this is it. So now it's going to be the program part. Program. So here we defined our functions, and now we're going to create our graphics program. So we're going to put 4. Now this could be a problem here, but it shouldn't. For x equals 0 to, actually, for x equals negative 10 to 210, and we're going to start with that and see what happens. Alright, so we should get that crossing of the y-axis. And I'm going to start with the first one to get an idea of what's going to happen here. So we're going to make our graphic piece. Actually, before we do any of that, I need to make a graphic screen, which I did not do. So I'm going to have to renumber this program. So we need a P mode, we need a screen, and we need a PCLS in there. So we need 3 lines. So we're going to renumber line number 1. And what this does is it renumbers the program. So now I have space up here to put the the graphic in. So P mode 1. That is just low resolution. Screen 1, 0. Or we can use 1, 1. That's a little more colorful with 1, 1. It's a different color set. And we're gonna PCLS it, which this is the same thing as the CLS command on the text screen. CLS will clear this, and PCLS will clear your graphic screen. And we want to make the background white for this, or it doesn't have to be, but we're going to leave it white. So that would actually be PCLS 5. Honestly, I don't know. I'm going to have to see what happens here. So let's see what we have so far. We should have a white screen. Syntax error in 5. Why do I have a syntax error there? Yeah, I don't know what's going on there. Strange. I'm gonna have to check this really quick. Just hang. Okay, hi, I'm back here. I had a technical issue. So, I'm back, and I figured out what the problem was. This is, I'll just, okay, so what I had done is I had done this a little backwards. So I have to fix this. Alright, so what you really have to do here is define function A, define function B, define function C. So the A, B, C goes on the outside of the parentheses. I had it on the inside by mistake. Haven't done this in a while. And the variable is always going to be x here. It's your input. If you don't know what a function is, this is your input and this is your range. So in other words, it's saying, for this one, it's saying y equals 1 times x plus 1. So that's what this is saying here. On the left side of the equals, this is the y. The whole thing would be your y. It's a little tough to explain. Hopefully you understand functions. And now we have the white screen that I wanted. The thing to note here is if you use screen mode 1, and I found this out the hard way, PCLS doesn't start at 1, it starts at 5, 6, 7, 8. And I found that out the hard way the other day when I was using P-Point, and I couldn't understand why it wasn't working. So that's worthy mention there if you're ever working with this. So anyway, we're going to try our first one and see what we're getting here. Now we need a graphic. We're going to use pset to set a point for our first function, function A. And it's always in the order of x, y. So our x is obviously going to be x, and our y is going to be function A. With its input of x, you have to put the whole thing. And we're going to make it, we have orange, magenta, cayenne. We'll start with cayenne for a color. I'm going to relist this. I'm going to put next x, list this. Jeez, list. So we should get a diagonal line. FC error and 10. Alright, well, I don't know what's wrong there. We're going to edit 10. X, comma, function A with its input of x, comma 2. Now I can't imagine what's wrong here, but I think I need another parenthesis. Nope. Now what could possibly be wrong there? Now let me check this against something that I know that works. Okay, I think the problem here is that I can't use 2 because we're in that second set of colors. So if I want cayenne, I'm going to have to change that to 6, and this should work. Still doesn't work. Why on earth isn't this working? I think it just wants to give me trouble. Okay, alright, now I know it's out of range here. Okay, so we're gonna have to edit 10. Now the problem is we need to move x over a certain number of spaces. I'm gonna try 20 spaces, maybe 10. We'll start with 10. Still doesn't work. Edit 10. Let's try and move it over 20 spaces and see if that works. No, edit 10. I'll move it over 50 spaces. Oh, jeez. Nothing. No. This is really odd here. We're gonna change this to, I think I'm just gonna leave that. I can't imagine what's wrong here. It's not letting me do this. So I'm gonna have to search a little deeper. Okay, back again for the second time here. This is definitely troublesome. Okay, so PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. So it's going to evaluate this from left to right, parentheses, exponent, multiplication, division, addition, subtraction. So we're good here. Okay, the problem seems to be in number 9. I don't think I'm allowed to use a negative number here for some strange reason. And I think that's what's causing this problem. So we're going to change this to 1 to 10 and see what happens. Okay, now we got a little line going on here. So I'm on the right track. Definitely on the right track. Now I'm going to have to extend that line. And the way you do that is by adding more numbers. So we'll try 60. That's a good long line. Now our y-axis would be going here. So we're going to have to create a, I don't know why that line is so thick. That's a very thick line, even for low res mode. I don't know why that line is so thick. We're in P mode 1, so we're safe there. It might be the angle of the line. So it's just thick for some reason. So we're going to try to do it on 100 there. And we're going to move it over. If that's even possible, I don't know. I don't know how I would even move this over. Well, we have too much here. 100 is way too much. We want to move this over to maybe 75. That should center it better in the screen. And it's not as thick now. Alright, now normally your y-axis would be right in the middle of the screen, so I'm going to call that good. Now before we go drawing any axis lines, I want to make sure that these lines are going to cooperate with me here. So we're going to set our next function the exact same way, but we're going to call it function B, because it is function B. You have to be wary of that. And we're going to go with color 7. This should give us 2 lines now. One of them hit the bottom there. So we're getting a steeper slope. So what I'm going to have to do here to stop it from hitting the bottom there is make this number a little smaller. 90. Hopefully it won't hit the bottom now. If it still does, no it doesn't. So now we have 2 functions displayed here. and one in cayenne, and the other in magenta. Okay. Excuse me. So we're on the right track. I'm going to keep going with this, and I'm going to display the next function as a graphic as function C, which is our last one. And we're going to make that orange. So what's going on here is that as we multiply x, the line is getting steeper. Now when we do this last one, this is going to be the most steep of all three lines. Okay, so this, well, we're going to have to change this again to a smaller number because now it's giving me an FC error. It's going out of range here. And I still have to change it to even less. We'll try 70. Maybe that'll work. Nope. Edit 9 again. 66. I just don't want it going out of range and get, not yet. Edit 9. Okay. That's good. It's still hitting, but it's not giving me an error. I don't want the top one getting too small. So I'm going to leave it. Well, you know what? Let's make it 62 and call it the end there. Now everything's perfect, okay? So the problem is here, you can see that the third one is the steepest line. And the first one, which was multiplied by 1, is the least steep. And then by 2, it increases twofold. And so, well, maybe this twofold here, maybe threefold here. And it would just keep getting steeper and steeper until it was a straight line. So, I did good here. And the only thing is that this computer is not designed for this type of thing. So our origin is, I don't know where our origin is, to tell you the truth. This can't be the origin. Well, it might be. It's a little sketchy because this seems to be, I think the origin would be right. Let me check this again. One, two, three. Now again, this is going backwards. This is negative 1y. I mean, yeah, negative. It's not. This is negative 1y, negative. I don't know if I'm saying this the right way. If you had a number line, you'd have positive 1, positive 2, and then negative. And then you have positive y, 1, 2, 3, and negative. So we're in the negative y's here. It's backwards again. This because of this, the way this computer operates. This should be positive 3, positive 2, positive 1, and you know, I honestly, and it's going, the slopes are going in the wrong direction, as I said at the beginning. They should be going from right to left. I honestly don't know if there's a way to fix this. I'm sure there is, but I don't want this video running too long, and I don't want to bore you. But this is just a demonstration of how to use your function command to graph different functions. I did x squared before, that was a bell curve. Now these are diagonal lines. I did correct before, but I didn't save a copy of how I corrected that, unfortunately, in the video that I made. I'm not sure if let me try something here. I'm gonna try it with number 5. Now I'm gonna try to multiply the entire thing by -1, and see if that changes anything. No, now I'm getting an FC error. Let's try to edit 10. Now this is getting really confusing, and I'm gonna have to add maybe 100 on there. Let me add 190. And there we go. Now it's going in the correct direction here, this green line. That's what we want. Kind of a cool design here going on too, but that doesn't really have anything to do with it. So let me fix these other numbers. I mean, go ahead and keep watching if you like math. If you don't, you don't have to watch, but some people might find this interesting. This is a little above beginner level, but it's not too complicated. It's definitely not beginner level computer programming here. This is more of an advanced program video, but we want to get our lines going in the right way, in the right direction, the right positive slopes we want, because these are all positive slopes, and we want our y-intercept to be correct. We don't want everything to be backwards. So I have to do this in order to correct that. A lot of parentheses here. Okay, and now they all match here. And we want to do our final fix here and add 190, and now everything's coming from the bottom and it's going in the correct order, and I can finish this. I can finally finish this. So our first one is a y-intercept of 1, our second one is a y-intercept of 2, and our third one is a y-intercept of 3. And this is the best I can do on this computer. Your x-axis is right here, and your y-axis would be through these first pixels here. And what I'm going to do is I am going to demonstrate that very quickly, and the only way that I know how is I'm going to have to change some of the colors here. I'm going to have to make them all one color, and I think I'm going to go with I can either make everything, why don't we make all of the graphs magenta, which is like a purplish color. That one's already purple. We're going to make them all the same. With no, okay. So that we can put a nice axis line in there. Grid line, I mean. And how I'm going to do that is I'm going to make a grid. And just going to very simply, quickly do this. We're going to do color, or I want orange. And we're going to have a line going from 0, 190 to 0, 255. And this is going to be our x-axis. Oh, buddy. still having problems here. 0, 190. That's backwards. 0, 190 to 255, comma 255, 190, and get rid of everything else. Okay, now we have our nice x-axis here. Now our origin is here at 0, 0. Our y-axis is going to go this way, and it would extend down. But we can't go into this area here because this is part of the border. So you're just going to have to use your imagination. That it extends down here. And these lines would extend this way. This one would extend this way into the negative area. Just use your imagination. If you have a graphing calculator, you can put in every one of these functions that I just showed you, and you'll get the same thing. But you'll get the full picture. This is just, here you're getting half the picture, but this is better than nothing. So we're going to make our last line here, and I'm going to have to list this again because I honestly got to find a center point, and I don't know where it is. I've been through this before. I think it may be 75, so we're going to try that. Line 75, 0, 2. We're going to keep it at 75 and go all the way to 190. I think that's the limit. And there it is, okay? So your limit, your screen limit this way is 190. And your screen limit this way is 255. So now we have our finished product here, and you can appreciate this much more when you do everything by hand. Now this was done in, how many lines do I have here? List 1 to 10. We have 10. List 10 to 20. We have 16 lines of basic. Make that 17, 18 lines of basic. So that's what it took to get this. 18 lines of basic, and this is as optimized as you can get it for this particular computer model here. The color computer 1 or 2, you can do this on at 1 megahertz with 23K approximately. And if I look at into the memory, it only took maybe 1K to write this. It's usually a little less than 23, so it doesn't use any memory at all, really. Just a little bit of memory. So Alright, that's the end of the video. I hope you watched through the entire thing. I know it was a little long, but now you know how to use a mathematical function that is part of color basic. And that's the end, so take care.